Hey you guys, welcome back. Let's do the rest of the study guide. So we stopped over here at question D. So this says 9b minus 54. So up here we talked about factoring. We're factoring these expressions. Now up here, especially if I was doing my own study guide, I would write this. Whenever I factor expressions, that means I'm doing the distributive property, but backwards, essentially. That's a good way to remember this, all right? And remember, factoring is one of the few things in math that's actually named pretty well. So whenever I'm trying to factor an expression, I'm literally going to find the greatest common factor. All right? I'm going to find a number that goes into both of these and pull it out of there because it's kind of like I'm simplifying this expression. Okay? So let's do this. We have 9b minus 54. If I find the factors of 9 and 54, I'm going to look for the greatest common factor. All right? So one trick whenever you're doing this, now that we've done this enough, we can probably talk about this. Whenever I'm looking at factors, I don't typically think of the factors for both of them and write them all out, especially if it's a number like 54. That probably has a lot of factors. I don't even know if I could think of all those, especially if I'm trying to do it on a test or if the pressure is on and there's a time component. So instead, what I'm going to do, I'm going to find the factors of 9, the smaller number of the ones I'm dealing with. Let's say I have a 1 and 9, and then 3. Oh, 3 and 3, because that actually multiplies. I can write it twice. It doesn't matter. Now, look, I'm going to look at the factors for the smaller number. I'm going to see what's the biggest number here of these factors that also goes into 54. Let's see, 1. 1 always goes into everything. That's always going to be a factor. Let's see, 3. Yeah, that goes into 54. 3. Does 9 go into 54? Yeah, it does. If 9 is the largest number that goes into 9, it's going to be the greatest common factor because there's no other number larger that could go into both of these. All right? So 9 is my greatest common factor. I'm going to pull that out, and that's going to go in front of my parentheses. Now, I'm going to divide both of these terms by 9. So 9b divided by 9. Remember, I just divide the numbers. 9 divided by 9, and that just gives me 1. So 1b. And I don't have to write the 1 in front of it. We can just leave it as b. 54 divided by 9, that gives me 6. And then I had a subtraction sign already, so I can leave that subtraction. This is 9b minus 6, all right? And I always double check my work by using the distributive property. I'm going to distribute that 9 out to see if I did it correctly. 9 times b, that's 9b. 9 times 6, 54, and I had that subtraction sign. If you also did this, if you changed it to 9b plus negative 54, the same process still applies. And in your parentheses, you would just have this, 9b plus negative 6. But it's important to recognize that that's the same thing as 9 and b minus 6 on the inside, okay? The same thing. Either way you write it, we would give you credit for it. But this is the simplest way to write it. And that's how you're going to see it when you see it as a question. Let's look at another one. Let's look at the next one. And give that an erase over here. Look at question E, negative 7a minus 56. So I have to go and find my factors because I'm looking for the greatest common factor. Now, whenever we deal with the negative numbers, that's really more, we handle them whenever we actually go and start dividing and simplifying this. But when I'm thinking about factors, I'm just thinking about the 7 there, all right? So the factors of 7 are, just 1 and 7. Now, this is where this is a major time saver. You could go and write all the factors of 56 if you wanted to. But an easier way to think of it is if it's a factor, that I'm looking for the greatest common factor, so it has to be the same on the 7s and the 56. So if I'm looking here, 1, sure, that's always a factor. And then there's only 7. Does 7 go into 56? Yeah, it does. So 7 would be my greatest common factor because that's the largest number that goes into both of them. All right? So I'm going to pull that 7 out of there, and that's going to be in front of the parentheses. I'll divide both of these terms by 7. Divide by 7, divide by 7. So now inside the parentheses, I have negative 7a divided by 7. That gives me negative 1a, but I'm just going to write negative a. We don't have to write the coefficient if it's just a 1. 56 divided by 7, that gives me 8. Then there was a subtraction sign already. Now this is one thing where it's kind of tricky. Remember when we were doing fractions, we would have something like negative 2 over negative 3. I couldn't give you full credit on a problem like this because I needed you to simplify it to 2 over 3, because I could actually divide both of these by negative 1 and simplify down to 2/3, okay? Same thing actually applies here. If it's a factor other than a positive 1, I should pull it out of there, okay? So looking at this, this is negative 1a, and this is really a negative 8 plus a negative 8. All right? They're both negative numbers, so actually I want to take those out, and instead I'm going to have negative 7a plus 8. It's kind of like if I went and wrote the factors and actually thought about them as negatives. We just don't typically do that because only in this case does it really matter. So I would think of them as negatives. Negative 1 and negative 1. That goes into both of those terms. So if it's anything other than a positive one, I should technically get rid of it and pull it out of there. Okay? So negative 7 is what I should pull out of there. And then a plus 8. And you can always double check your work again for these things. So negative 7 times a gives me negative 7a. Negative 7 times 8, that gives me negative 56, which, again, this is really plus a negative 56. All right? That one's kind of tricky, I know. But the more you do it, the better you're going to get at it. Okay? Let's look at the next one. 24x minus 30. I've got to find the greatest common factor. Now, another helpful trick you could do for these is to think, what goes into 24 and 30? You know what it can't be? It can't be a number greater than 6. Because look, the difference between 24 and 30 is just 6. So, does 6 go into both of them? Yep, it does. 8 can't go into 24 and 30 because think, 8 goes into 24, but 24 plus 8, that's 32. 30 is not does not have a factor of 8. So the largest number that could go into these is just 6. Again, you can write them all out if you want to, especially if you're not really sure. That's just fine. Otherwise, you can try and think, what goes into 24 and 30, the largest number that goes into there? It would be a 6. So let me pull that 6 out. I'm going to divide both of these by 6. If you want to change this to plus and negative, you always can. All right. So 6 is on the outside of my parentheses. Now 24x divided by 6, that gives me 24 divided by 6. That's just 4x. Negative 30 divided by 6, that gives me negative 5. Then I had this plus in there, all right? You could leave it like this or simplify it a little bit further to 6, 4x minus 5. These are the same expression, and it's important that you can see that they're equivalent, okay? All I've changed is the plus negative versus a subtraction sign. Let's look at the next one. Which expression is equivalent to this? So this is showing me that I need to do the distributive property to figure this one out. So I'm going to distribute that 3 to everything inside the parentheses. 3 times 5x, that gives me 15x. Minus, let's see, 3 times 4y, that gives me 12y. So I'm looking for 15x minus 12y. Oh, hey, it's right there. Perfect. Let's look at the next one. Which expression is equivalent to 20x plus 4? Now, two different ways you could do this. You could factor this expression and find the GCF, the greatest common factor, and try and set up one of these just like we did on the previous problem. Or you could just go over here and actually use the distributive property on all these answer choices. And I always like that a little better. So let me go do that. I'm going to go and distribute all of these expressions. 8 times 2x, that's 16x. 8 times 4 is 32. Oh, so that one can't be it. Distribute the 4 times 5x is 20x. Plus 4 times 1, that's just 4. Hey, that works. Let me double check and just make sure these don't work either. 8 times 12x, wow, that's a big number. That's like 96x. That already can't be it. And then 8 times 4, that's a 32. That also for sure doesn't work. Let's look at the next one. 4 times 2x and 4 times 8. That gives me 8x plus 32. Again, doesn't work. That's not what I'm looking for. I'm looking for this one right here. B matches. All right, I'm going to give that an erase, and we're going to scroll down and do the next set of problems. Let's look at number 6 right here. Please identify the property for each of these expressions. So we have 5 main properties that we talk about. We have the commutative property. That's where we change the order. Remember how commutative starts with a C and an O? It always reminds me, C and O in commutative. C is for change, O is for order. Change the order. Associative property, that changes the grouping, all right? The grouping is changed. So like the parentheses might be around different numbers. Let's look, we have the distributive property, which we know very well, all right? We have the inverse property. And we might see that in different ways. We could see the inverse of addition, where we add 2 opposite numbers and get 0. The additive inverse equals 0. When we multiply inverse numbers, we're talking about 3/8 times 8 over 3. Remember that word reciprocal we talked about? We say it a lot in here. When I multiply the reciprocal of a fraction, I get 1. All right, so when we multiply, we get an answer of 1. And then the identity property, let me write it down here. That's just when we're either going to add 0 to a number, x plus 0 equals x, or x times 1 equals x. Notice how the identity of the number I start with doesn't change. That's the identity property. So let's look at these. 3 plus 5 plus 8 is equal to 5 plus 8 plus 3. Let's see. Same numbers. Looks like the order of the number changed. 3, 5, 8, 5, 8, 3. If the order changes, we're talking about the commutative property. Let's look at the next one. Negative 13 plus 0 equals negative 13. That negative 13 doesn't change. The identity of that negative 13 stays the exact same. Because when we add 0 to a number, it doesn't change the identity of that number. So this is the identity property. Let's look at the next one. 12 plus 20 plus 9, parentheses right here, equals 12 plus 20 plus 9, parentheses moved over here. The numbers are the same. The order of the numbers is the same. It looks like the only thing that changed is the grouping. These are in parentheses, then these are in parentheses. If we change the grouping, we're talking about the associative property. Let's look at the next one. Which property does this expression show? Looking at this, let's see, 5, 4y minus 2. This might take a little bit of thinking. You know what it looks like? It looks like someone distributed that 5, because 5 times 4y is 20y. 5 times 2 is 10. There was subtraction going on. Looks like this is the distributive property. All right? Let's look at the next one. Please use the following expression to answer these questions. Question number 1 says, how many terms are in this expression? Remember, terms are the parts of the expression that are separated by addition and subtraction. All right? So if I was going to ignore all the subtraction signs and addition signs, everything else is a term. So let's see, I have 1 term, 2 terms, 3, 4, 5, 6, 7. I have 7 terms here. Let me give that an erase, though, just so we can see the expression again. Now it says, identify the coefficients. Remember, coefficients are the numbers with a variable. That word co, like a co-pilot or co-teacher, kind of means you work together. So the number with the variable. The coefficients here are, let's see, 5, because that's the number with that letter A, that variable. 13c. Now this is where things get a little confusing because I really have to remember that's a negative 13 with that c. All right? If I change the subtraction sign to addition and the sign of the following number, that's a negative 13 with that c. Let's look at the next one. 8, that's a constant by itself. Change this subtraction to addition and the sign of the following number. So negative 4 is with that variable g. Change this subtraction to addition and the sign of the following number. Now look, this says plus negative x. There is no coefficient with that x variable. But if there's not a coefficient written, I always know there is a coefficient of 1. Every variable in the entire world has a coefficient. It has to have a coefficient. Sometimes we just don't write it if it's a 1. So that is a coefficient of negative 1. And then the 2 is with the y, that's the coefficient, and then that 5 is by itself. Let's look at the next one. Identify the variables. The variables are the letters. So I have an A, I have a C, I have a G, I have an X, and I have a Y. It's all the variables in that expression. Identify the constants. Let's see, constants are numbers that are constantly alone, completely by themselves. Let's see, that has a variable, that has a variable. Oh, this one, 8, no variable, that's a constant. Let's see, that has a variable, that has a variable, that has a variable. Oh, this one doesn't. But remember, this is plus a negative. That's really a negative 5 right there. And the last one, rewrite that expression using only addition. Let me erase that so we can rewrite it. So if I was going to use only addition, I would have 5a plus negative 13c. I keep the parentheses there just to separate the plus sign from the negative sign. Plus 8 plus negative 4g. That's a negative. Plus negative x plus 2y plus negative 5. All right, so that's this part of the study guide. Thank you guys for sticking around, and check it out in the next video. Thanks.